This is the fourth video on section 6.6, Lagrange multipliers. Here we're going to find the maximum and minimum value of f of x, y, z equal to x times y times z, subject to the constraint 9x squared plus 36y squared plus 4z squared is equal to 36. So we define our function g to be this sum minus 36 to use Lagrange's theorem. We're trying to find the maximum value of f subject to the constraint g of x, y, z is equal to 0. So we look at our equation. Gradient of f is equal to lambda times gradient of g. Calculate the gradients. And we look at the equations given by the components, right? So we have from the first components, yz is equal to 18 lambda x. Xz is equal to 72 lambda y, and xy is equal to 8 lambda z. So we look at our components, our first, second, third components, and we have these equations. So now we need to work with these equations. As we're doing this, sometimes when we're using Lagrange multipliers, we have to get a little bit creative. And there isn't any one just sort of pattern technique for this. And so we started with these three equations right here. And we're going to multiply the first one by x and have 18 lambda x squared is equal to xyz. We multiply the second one times y to give us 72 lambda y squared is equal to xyz. And then we multiply the third one by z to give us 8 lambda z squared is equal to xyz. The nice thing about that is on the right side of these three equations we have xyz. So let's add xyz to itself 3 times. So 3 times xyz is equal to what? Well, 18 lambda x squared plus 72 lambda y squared plus 8 lambda z squared. So that's what 3xyz is equal to. But let's factor out a lambda. If we factor a lambda out of this, what does our constraint tell us? Our constraint tells us that 9x squared plus 36y squared plus 4z squared is equal to 36. When we factor a lambda out, we have exactly 2 times that. And so what we have is we have 72 lambda. So that 72 lambda, again, comes from factoring a lambda out and noticing that from our constraint, we just have 2 times 36. That's what we have here. So divide both sides by 3. We have xyz is equal to 24 lambda. Now, if lambda is 0, then 2 of x, y, and z are 0. Why? Well, let's go back here. It's probably easiest to see it here. If lambda is 0, then y times z is equal to 0, which means 1 of y and z is 0. If lambda is 0, x times z is 0, which means 1 of x and z is 0. And if lambda is 0, then y times z is 0, which means 1 of y and z is 0. So when you put these three together, that would give us, if lambda is 0, then 2 of our variables are 0. Even if you don't believe that 2 of them are 0, you at least believe that 1 of them is. And in either one of those cases, f of x, y, z is equal to 0 because f of x, y, z is simply the product of the 3. So what is my point in all of this? You don't have a max or a min if lambda is 0. So let's go back to these equations right here. So we have our 18 lambda x squared equal to xyz. We now know that xyz is 24 lambda. Go back to the second equation. Again, we now know that x times y times z is 24 lambda. The same thing for the third equation. And we're assuming at this point that lambda is not 0. Because if it is, we know what will happen. So we're assuming that it's not. So we divide by lambda. That gives us 18x squared equal to 24. Solve for x. Right here, it gives us 72y squared is equal to 24. Solve for y. For the third one, we have 8z squared equal to 24. solve for z. So we have x is plus or minus 2 divided by square root of 3, y is plus or minus the square root of 1/3, z is plus or minus the square root of 3. So we have 8 points to consider. Why? Because we have 2 possibilities for x, 2 for y, and 2 for z. 2 times 2 times 2 is 8. So we have 8 points to consider. But of those 8 points, we're only going to get 2 values. Our max is going to be, let's say we multiply 2 divided by square root of 3 times 1 divided by square root of 3 times square root of 3. We have 2 divided by square root of 3. For the min, let's suppose we choose 1 negative and 2 positives. And so when we multiply those, we're going to have negative 2 divided by square root of 3. So of our 8 points that we have, 4 of their function values are 2 divided by square root of 3, and 4 of the function values are 2 divided by square root of 3, and 4 of the function values are negative 2 divided by square root of 3.